Hi and welcome to video about global warming, CO2, climate change and so on. So this is a video I try to explain you with some graphics and data what are really the key facts of global warming, climate change and so on. And I'm also really interested in your feedback in, do these things work? Do they make sense for you? Would you use some other diagram and so on? It's really how can I explain to somebody really the problems and really the urgency of the situation. So let's go into medias res. We are going to talk about global warming, and climate change then is something which happens because we have global warming, and especially about CO2, which is one of the greenhouse gases, and of course there are other greenhouse gases, but we are going to focus on CO2 right now. And the first diagram I wanted to show you is the atmospheric levels of CO2. And they are measured since the 1960s. So this is a diagram from 1960. And there is a very famous reference point in Hawaii, I think Mount something, where they measure the CO2 concentration in the atmosphere all the time. And this is one diagram which is just taking the yearly averages here. So it's a yearly diagram from the 1960s. And you see, well, first of all, it's quite striking that you see the CO2 concentrations rising all the time. So here the lowest point is something like 315, 315 parts per million is a figure. And now in 2024, we have reached 425 parts per million. So you see that it's going up, and also, you could see there that it's not going up like a straight line, it's like a bending line. It's curving upward. And this is because we put more and more CO2 in the atmosphere all the time. That's why it's curving upward, But this is really the measurable thing in the atmosphere, how much there is. And of course, there's all kinds of effects. You put more CO2 in the air. Not everything arrives really in the atmosphere. And then something is taken away from the plants and so on. So it's a very complicated process. But this is real data on planet Earth showing that the atmospheric content of CO2 is rising, and it seems with an always higher rate. So why is the CO2 so important? Well, the first thing is that CO2 is a greenhouse gas. It's, the sun is shining on our planet, and, it's all this energy comes in, and then it's also going out to space. Otherwise, our planet would heat up really very fast, and we would all die really soon. But, there's energy coming in, and it's radiated out. And the CO2 behaves like a blanket. It's keeping more of the stuff in. And it's just a very tiny fraction what this kind of change is. But we have a really very good data in science, because in the Arctic, people have drilled ice, and they could take tiny bubbles and find out how old this ice is, and also how much CO2 is in these tiny bubbles of air. And they could also find out over the time how high the temperature was. So that's science. And these guys, they came up with this diagram here. And this is over the last 800,000 years. So it's a very long time. It's partly it depends on these ice core samples. And you see here that this is 0. This is where we are today. And this is 800,000 years ago. And this diagram shows you two things: CO2 concentration, which is the deep blue, and the temperature, which is the light blue. And they have been made in this diagram that these lines match. So you have a very high correlation here. In statistics, if you have two values and they behave similarly, you have a correlation. And the thing is, you don't even have only a correlation that some things happen together. No, you have a causality. One is causing the other, because we know the science about this. And that is showing here that, when this goes up, the other one goes up as well. So they are almost matched all over the time. Really good. This is really good data. It really convinced me. Oh, yeah, well, this is really convincing that, when the CO2 goes up, the temperature goes up as well. And, this is really enormous time frames here. Thousands, hundreds of thousands of years. And there have been warm ages when it was really warm, like here, and ice ages when it was really low, like there. And you have different concentrations of CO2 in the air, over these times. So the lowest one is like 170 parts per million, but the whole thing never went about 300 over the whole time. So it was like 170, 300 was like the range. This is going on. And there's like processes here that when, that it fluctuates. It's like we are changing, we're going from an ice age to warm age and back. It's like going back and forth. If you look at the stock market, it would be something going back and forth. And this is a stock going sideways, you would say. But you see, there's a very high correlation between these two things. And here you have like the figures, 170, 300 is like the highest. And then you have here the temperatures in Celsius, and the lowest temperature here is -9, -12 from the reference point, and +6. So this diagram here, you could say that you have roughly a 1 to 10 relationship. So for 10 units of CO2, there's a change on the global temperature of like 1 degree Celsius. 1 to 10, right? So where are we today? Same diagram here, but just the CO2 concentration from NASA, and you see the fluctuations all again, the 800,000 years. This is where we started, 280, that was before industrialization, and this is where we are going. 425 is like the latest measure, and we are shooting it up so fast, it's not comparable with anything here. Anything, no. Because we are like only like taking 100 years or so to really pump up the CO2 in the air. And the time frames here, one dot is like 1,000 years. So we are not like, it's like a tenth of a dot, and we already exceeded, the range of this. And we are going faster and ever faster there. And just remember, there was like a 1 to 10 ratio for temperature. It's not going to stay like this really forever. It's in this range you have a 1 to 10 ratio, but you see, it's dramatic here. If you, so we're going to see the temperatures in the next step. So where are we with temperatures? This is the global surface temperature, and again here is like the reference period of where the people are talking about is 1850 to 1900. This is like the reference period. There you take the 0 to how many degrees you are, the temperature have increased. And of course, it's going up and down, it's like, fluctuating. But you see, well, it's going up, and it seems to go up faster here. And, it's like at least going up straight. And maybe there's even an upward trending curve. Why? Because we have seen the CO2 is increasingly going upwards. So the temperature is increasingly going upward, but we only have 1.5 degrees, or 1.55 degrees was in 2024 compared to the reference period. So that's like this marker there. Because, the world is like full of water. That stuff is not heating up that fast, because we have like this enormous mass of water. It's deep, it's sucking, it can take up lots and lots of energy. So it's not going to be that fast. In these other diagrams, you have like thousands and thousands of years. We are only like doing this like now 50, 60, 100 years, having these high CO2 concentrations. So the warming up is like delayed. It's like maybe if you are, if you have like a heating at home and you switch on the heating, it's not that your house is immediately warm. It takes, if the house was cold and you start the heating, the heaters, it's not going to heat up so fast. It takes like maybe hours or so, like the whole house is going to become warm. So there is a delay, and that's really the problem. So what are we doing here? You see the how much carbon dioxide we put into the air. This is carbon dioxide from fossil fuels. And it shows that we put, this is not the concentration, this is the amount of CO2 we produce every year. And you see that, this comes from fossil fuels. This is like Second World War here. And there's just like around 5 gigatons of stuff. So, and this is like already industrialized thing, like industrialization. So, but we have been like around the 5 gigatons of CO2, 5. Really low. And you see that why in the beginning of the temperature, the increase wasn't that big. Because here we just put in, after the Second World War, on during the third, we were around 5. 5. So, and today, and this is only from fossil fuels, today we are around 37 gigatons of CO2 per year. This small tiny blip here is COVID crisis. They are like something happened and we just put in a little bit less. But still, it just was a minor dent. This is Second World War. This is today. We are putting out ever more CO2. And you could say that this is like constantly increasing. It's if in statistics you would draw like a straight line here and you would say that's quite a good approximation. Like every year we put out more CO2 in the atmosphere. That's really the problem. Some people think, oh, we are doing so much. No! The real thing is that the CO2 concentration in the atmosphere is rising ever faster. That was that diagram. And here you see that we produce ever more CO2. And there's also land use change. So if we are burning forests, that comes on top of this. But this is just like the CO2 which comes from fossil fuels. So now a good question is, where is this going? Well, here, of course, scientists are all, there's a lot of people thinking about this, where is it going? And here the black line is the CO2 production. This is like here the historic production in gigatons, and you see this. This is like this graph I just showed you. And now you have different scenarios. Where are we going? There's like, here this is like the worst case scenario is like, the world is growing ever richer. Everybody wants to burn stuff. Everybody wants to have cars. We are burning more and more and more. We like burn until nothing is left. This is like saying, hey, we just like triple the production of CO2 within the years. This is until the year 2100. And this is only coming from that there's like a peak in production. There's not much more stuff, fossil fuels available. We run into resource constriction, which isn't really, never really going to happen, but that's what they assume here. The other one is like, hey, the red line, and they are all like sort of red, but they like the red line here, they are thinking, oh, the same trend, which I just described, which I say, yeah, that's like, yeah, we are always producing more and more of this stuff. So it's like going straight up. It's like that white line. And then they have these scenarios where the people think, oh, here the blue line is, hey, we are going to stop producing CO2 immediately, which never happened, because we are already over this diagram. Also there that we see the trend is reversed. It is not. We are still on the red line. And then some people say, yeah, but like for some years we are still increasing, but then it's going down. These are like the people who are telling you, yeah, it's going to become better in the future. Like don't worry that for the next 5 years or 10 years we are still increasing, but then it's going to happen. Yeah, this is like you have to believe in that something happens, and maybe something happens, but I would guess it's somewhere in between. You have to take your guess. My guess is, as long as we have all these fossil fuels available and they can be burned and they are still quite cheap, it's going on like this because the whole world is becoming more and more reliant and likes to use energy. So this is like how much CO2 will be produced. And then you have like on the other side on the diagram, you have how high the concentration of CO2 is going to be in the atmosphere by 2100. So again, you have like these color codes. And in the worst case scenario, we are going to be somewhere around 1100 parts per million. That's like really going to be a lot. Yeah? But even in this, like, I would say the red scenario is like quite likely. We are something about 850 or so. Yeah? And even in the good scenario where we say, yeah, in some years it's going to happen something, we are decreasing, you are still exceeding 600 parts per million. Yeah? So these are these ones. So, and if you say like, well, that scenario is maybe too extreme, that's maybe too extreme, yeah, and maybe something like this is sort of happening, you would end up between 600 and 800. So let's say 700. Okay? Just, get this figure. But this is like, what is your scenario? What do you think? Well, I think so far the only thing I see is in the figures, in the data I see is the red one. We are going to produce more and more and more, and there's no reverse of anything. By the way, it would actually be really simple for the whole world to stop using this, because if all the governments who produce fossil fuels, it's like 20 governments in the world, have to decide on, we just want to decrease production, it's a no-brainer. These 20 countries just need to say, hey, we are going to produce less of this stuff all the time. We're going to sell less of the stuff. Maybe the prices are going to increase. But, it's really simple to say, hey, we just throttle production and the world has to change. It's really simple. But are they going to do it? No. So, and now comes the big question, because we have seen in this diagram here that there is a correlation, there's like a correlation between the temperature and the CO2 concentration. And this is 320 and there's like 160, so we are going to levels which are around here. So this kind of data isn't even valuable anymore. And by the way, the highest temperature you had here was like almost 5 degrees higher than reference period. So that's already some degrees, and with comparable, there was like here 300 something parts per million, and measured between 3 and 5 degrees Celsius more. That's something, like 300. But now we are going in the direction of 600, 700, 800. This diagram can't be used to predict this anymore. You will say, it's probably going to be a whole lot of warmer, in the end, when there's like an equilibrium. But what kind of temperatures are we going to? Because these concentrations we are going to haven't been there for a million years. They haven't been there for, by the way, tenth of millions of years. So now we come to this. So if we can only, look at data, we can look at how long ago actually has been these kind of CO2 concentrations in the atmosphere, in the prehistoric times. Yeah? And that's like this diagram. So it's actually quite complicated, but I try to walk you through this. This is all about CO2 concentration, and it's not a linear scale. There's like 100, 200, 100, 200, 500, 1000, 2000. So it's not a linear scale. And also in this direction, it's not a linear scale. So we are actually here. This is like the 0 line. Yeah? Or we are like there. Yeah? Okay. But this is like 1,000 years ago, 10,000 years, 100,000 years, 1 million years. So this diagram I showed you before, it's like this kind of thing here, which is fluctuating. Okay? And now we have like 1 million years, 5 million, 2 million years, 5, 10, 20, 50 million years. And here 100 million, 200 million, 400 million years. So it's like really a long time ago. And of course, measuring the CO2 concentrations 50 million years ago isn't really simple. So it's a little bit getting, not so easy to measure them. But let's assume that the science is correct. Yeah? And what they measured is this black line. And all these dots are measurement points. And they averaged this out and said, okay, we just take an average, and that's like this. So you can say, is it really valid? We don't know. But you will see that, this is like hundreds of millions of years ago, and the CO2 concentration is like going down. Yeah. This is like, we know that all these fossil fuels, they come from somewhere. They come from like plants or animal organisms, biomass, which went into the ground and was produced to fossil fuels. Yeah? So we know that there was CO2 in the air, that the CO2 concentrations in prehistoric times in the earth have been higher, and that there were all these bioprocesses which produced biomass, like trees and stuff, which for some reason ended up in the ground, like, for example, brown coal, yeah? or other kinds of organisms in like seas and lakes and, in the open sea, went to the ground, and then for some processes in geology ended up in fossil fuels. So we know that CO2 in this process was taken, carbon was taken from the atmosphere and put into the ground. And that's why you see that the overall trend of this figure is it's going down. And sometimes it goes up, and of course, it's like with all measurements. But you see the overall trend is going down. Like let's take this figure here that it goes down, and then it has been in a certain area. So this dotted line here, by the way, is 400. That's like a value which already has been breached. We are already at 425. So you see that the 400 has been breached. We are over 400 right now. And it was well below 400 for an awful lot of time. And you could say, hey, when is 400, when is it actually, has it been there, this kind of thing? And, there are maybe some measurements around here, 2 million, between 2 and 5 million, where scientists have found that there is maybe something like 400, there are these dots. But, if you look at the average curve, you would say, hey, you really have to go back about a 10 to 20 million years to ever see a breach. And now here are our, the colored scenarios are here. This is like the worst case scenario. This is like the bad scenario. And, we are like somewhere there. So you could say this is like the yellow line and the red line. So somewhere below this other line, which is like 1,000 parts per million. Huh? So, and then you can ask, when have we seen these kind of values? And you see, hey, it's about 20 million years ago. Oh, that's like 20 million years ago was a time when CO2 concentrations have been in similar levels where we are heading to. So we are like 425. We are going somewhere to 600, 700, 800. We don't know really what's going to happen, but assume that the yellow was already a quite nice scenario. The one is maybe more likely, but let's say somewhere between here. But if you look in prehistoric times, you have to go back something like 20 million years. And if you assume that we are breaching this, that we're really burning more, you go back to times which are around 50 million years. So the important point is, we already put more CO2 in the air, which hasn't been there. Some scientists say like 10 to 14 million years ago. We haven't seen these levels like today, which we already have. And we are going in the direction of 20 to 50 million years ago. So now the question is, you could ask, how high have the temperatures been? Do we know how high the temperatures have been there? Because we can use these ice cores up, but we can't really take them for these predictions so well, because they are so different. Yeah? It must be warmer, definitely. So, another diagram, same thing. This is again the same thing, but we have like the time here, and it's again it's not a linear scale. This is 0. This is like 10,000 years. This is like 1 million years, 5 million years, 10 million years, 100 million years, 500 million years. So this is like really stretched out in time. And here we have the temperatures. Yeah? So we have the temperatures, and we have here temperatures in Fahrenheit on this. So we have to look at this. This is like the Celsius line. This is Fahrenheit, wrong units, but there's like the lowest one is -6. And here is plus 14 degrees is the high. So the real question is, if you say, if you look at this, you see that it seems to be, that was like fluctuations, there you see it's going up. This is like the 2 million years, and here we come to 5 million years. Oh, and that's interesting, because there it seems to have been stable for quite a while, But if we go, this is like the time frame here between 10 and 20 million years. You see that here they found, temperatures are quite higher. And if I look at the side, it's 4 to 6 degrees Celsius warmer. But the problem here on this diagram is it's not against the usual reference. It's between the reference of 1960 to 1919. Yeah? So you have to add a half a degree or so to the normal thing. But it really doesn't matter. We are going to be 4 to 6 degrees warmer with the levels we are already at. But the levels we are going to are somewhere here. Yeah? And the highest point of this is like 14 degrees there. But, you know, if you just say, oh, it's maybe something like 10 to 12, these are things which have been associated with CO2 concentrations. Can you say that it's going to be there? No. Is it going to be there within like in a short time frame? No, because all these changes took like thousands and thousands of years. So the whole temperature has to eat up. But, you know, the CO2 concentrations we have and we are going to are associated in science with much higher temperatures, 4 and 6 degrees for what we already are, and in the area of 8 to 12 degrees more in the maximums we are going to. So what the key message is, hey, if you just look in prehistoric times, the CO2 concentrations we have and we are going to are associated with really high temperatures, you know, much higher than what some people tell you it's 1.5 degrees or 2 degrees. No, that's going to be, it's associated with something really, really much higher. It can be like 4, 5, 6, 8 degrees, stuff like this. So that's really the problem. So where are we heading to? You know, this is, you know, you have heard of the Paris agreements. And, you know, one thing really to predict the future is really hard, especially in climate science, because the climate of the problem of the planet is really, really, really complicated. So what people have done, they said on these Paris agreements, they said we want to limit climate change and global warming. We want to limit global warming to well below 2 degrees Celsius until the year 2100. Okay, and then they said, okay, we define something like a budget, how much CO2 we are still allowed to burn and put in the air, that we still reach this target. And then comes up stuff like this. And it says to reach the 1.5 degree target, and this is already an outdated figure. You know, it's just going to be something like, yeah, it's, we would have to go to reach the 1.5 degree target. We have to go down into zero, like almost immediately, just several years, you know. And the more we still burn, the steeper this has to go. And the same for the other ones like 1.7 and 2 degree target. Because, you know, we just saw, hey, we already reached 1.5 degrees warming. So how much of a chance do we have that it's going to be limited to 1.5 degrees? We just have to stop producing CO2 like immediately. We actually probably have to get it out of the atmosphere. You have to go below zero. We have to really get CO2 out of the atmosphere again to reach 1.5 degrees. But you know what the real problem of these graphs is? There are probabilities associated here. They say, hey, with a probability of, I think these are calculated with 50% probability. With a 50% chance, we are staying below 1.5 degrees. It's not that the scientists are saying with a 90% chance or an 80% or 95% chance we are going to be, no, with a 50% chance. Come on, 50% chance. It's like if you want to have like to be much more likely to achieve this, we already exceeded the values. They can't even do something like 95% because with a 95 we are staying below 3 degrees or something. Yeah. So the problem of all these graphs is that they are coming with a probability, and the probability which is used in these things is 50. Sometimes, you know, if they are like more conservatives, they use figures for 67%, but not more than that. Because otherwise it would say, hey, we have to stop emitting CO2, and the 2 degree target, the 1.5 degree target is my personal perspective now. 1.5 degree target is absolutely out of the door. If you talk about this, that you could even achieve this with what we are doing right now in producing ever more CO2, it's out of the door. It's like completely insane that you even talk about this. The same is true for like talking about a 2 degree target. Because if you would try to sell me a 2 degree target that we stay below 2 degrees, then we would have to say, hey, I would like to see this at least, let's say, 80% chance. That's like Pareto principle. There's like 80%, but I would say, hey, give me at least a 90% chance that this value is going to get achieved. But if you would say we have to take 90%, we again have to go down like this. And that's what everybody knows. It's like everybody agrees, we are not going to stop anything. You know, it's like I interviewed a lot of people about this recently, and most people think, oh, we are on a good way. We are not. This is like really the problem. You know, that's why I started with this thing. The concentration of CO2 in the atmosphere is going up all the time. It's going up, and it's going up with an ever increasing rate. And from my perspective, all these scenarios, the one where we are going to in the direction something around 800 parts per million at the end of of 2100, that's like the thing which is more likely today. Because even if in some industrial nations like Germany, we are doing quite a lot about, like to use less fossil fuels and so on, to build houses and be very conscious of CO2. But like if the rest of the world is still using the stuff and burning it, it's not going to make any difference. It's just getting cheaper, and then it's going to get burned anyway. So this is like the facts, and you can do your interpretation and how serious the topic is. I say the summary is CO2 concentration is rising all the time. The CO2 concentrations we see already is like 10 to 15 million years ago. And where we are going to are CO2 concentrations we have seen between 20 and 50 million years ago. And these prehistoric times have been associated with temperatures of like 4, 6, 8 degrees and more Celsius than the reference point. So the warming we are going to is not going to be limited to anything. It's going to be much warmer, and that will have absolutely drastic things in life. And so if you have children, your children are likely going to see this and experience this. And so we have to do something. I think really there are possibilities to reverse the thing. The most simple solution would be that the 20 most countries which are producing most fossil fuels would agree, hey, we are just taking one of these graphs and we are just telling the world that, this year we are producing the same as last year, and then we are going down with a certain decrease every year. And we tell this to the world, and then for like 10 to 20 years, 2 decades, the whole world has time to change, because then we are like practically down. And at the same time, we are doing something to really take out CO2 from the atmosphere. It's possible, but we have to start and do something. So you can start by following this channel, leave a like, subscribe, comment, and so on. Thank you very much for watching.